the last classes what we have done is that we have talked about the K-map. So I have given you the introduction about the K-map, that how we are making a K-map. So K-map, generally we are using it for the SOPs, okay, sum of product. However, you can also use for the POS, but the format will going to change. So right now we will be talking about the SOP only. That means where we will going to insert one. And I have also told you about that these K-map, that the nomenclature which we are using in the K-map is used with the help of a gray code, because the distance are 1 unit apart. Whenever you are moving from one block to the another block, so the distance which will be moved will be a 1 unit apart. Therefore, when you are doing the numbering of a K-map, you have got a unique numbering in a K-map. So this was the 2 variable K-map we have shown you, and this was the 3 variable K-map which I have shown you. So we will going to continue from this. So what I can do is that I can simply write it in this form. So I have to draw this block like this. So if I am writing here A, I can write BC here. So I have to write here A bar and A, then here B bar, C bar, then B bar C, then BC, then BC bar. And the filling which we are doing here is like we are putting M0 here, M1 here, M3 here, M2 here, M4 here, M5 here, M7 here, M6. Why we are using this K-map method? Because we have to minimize it. So in a similar way, if I go at the back side, what I can write here, I can use this as a M0. So let me write it as a M0. I can use it as a M0, M1, M2, M3. So this is the 2 variable, and the previously which I have shown was your 3 variable. So in the 3 variable, what we have to do? We have to write it M0, M1, M2, M3, M4, M5, M6, M7. So generally when we are writing this, we can write it in this form also. Let me draw it again. A and here BC. So what we will going to write here, we will going to do the numbering like this: B bar C bar. B bar C bar means we are using it as a 0 0. Then B bar means 0, C means 1 0 1. Then 1 1 1 0. And here we will going to write 0 1. So this numbering is also clear. How I have written this number? 0 0 0 1 1 1 1 0. So you will going to see that if I take this one, if I take this one, which one is common in this? 1 1 1 0. Which one is common? B. The B is common. Yeah. So B is common. So we will have B here. So we can say that B is common here. And if I take this one, what is common? C is common. Okay. So let me take this color. So this, let's say this is your C. So I've said that whatever the value will be present here in this blocks, whatever, it will always going to represent your C, and whatever the values are present here, it will going to represent your B. Is it clear? And whatever the value is present here, it will going to represent your. So basically, what is the concept of a K-map? The concept of a K-map is that if you are in this block, so if you are moving here, it should be one distance apart. If you are moving here, it should be one distance apart. Is it clear? And if you are here, then if you are moving here, it should be one distance apart. If you are here, it should be one distance apart. Means you have to check out. Okay, so this is for, let's say, 2 variable K-map. If you draw similar for the, so it will be something like this. Okay, so let's say if you are here, so where you can move here, you can move here, and you can move here. So they all should be at one distance apart. Okay, so all condition has to be met. Okay, therefore the K-map are being designed in such a way, and therefore these K-map are being based on the gray code. So one method is to represent a K-map like this, A, and here we are writing BC. So we have to write a nomenclature like this. Sometimes you can also write this K-map as an equivalent of this. That means if you rotate this one like this anti-clockwise, you will get this picture. You are getting, if this is your M0, M1, M2, M3, M4, M5, M6, M7. So this was A and BC. In a similar way, what you can do, you can just rotate this K map and you can have a position like this, which I have drawn in the second. So you can write it in this form, like here you can write A again, and here you can write BC. So your nomenclature will be like this: M0, M1, M3, M2, M4, M5, M7, M6. So this is how we are forming the K map, 2 variables and 3 variables K map. Let me take some example of a 2 and a 3 variable K map. So let's say take an example of a 2 variable K map. So as you can see in the 2 variable K map, the structure is like this. Whenever you are going with the 2 variable K map, you have to form a group. You have to form a group. Whenever you are solving this K map, why you are solving this K map? To minimize the function. Whatever the function is given to you, you can minimize it. Okay. So whatever the function is given to you, you have to form it in a group. So the maximum pairing in this 2 variable K map, what we have to do, we have to make a pair. So whenever we are talking about the pairing, we can make a pair of 2 variables, can use 4 variables, or we can make a pairing of 8 variables. Okay. So how we are going? We are going with the variables making in the 2 raised to power. So we have 2 raised to power 1, 2 raised to power 2, 2 raised to power. So why we are going like this? Because we are dealing with the binary. So we have to make a pair. So if I ask you what is the maximum pair you can make? Okay, so the maximum pair you can make is like, that means you can cover all the blocks. Like if you have a value present here, you can make one pairing, that is of 4. In a similar way, if I draw this again, suppose your inputs having like this, you cannot make a pairing of 4. So what you have to do? You have to make a pairing of 2. You can take this one and you can take this. So this is clear to you? We can go with the pairing of 4, we can go with the pairing of 2. And if we have got only one variable is left, we'll select that one only. The concept of pairing is that you have to minimize the code. For example, let's say I have a value like this. I have got some function 1, 1, 1, and here I have got 0. So what we are taking, we are using a SOP. We are using a SOP. So if I write this individual function, so let's say this is my A and this is my B. So this will be my A bar, this is my A, this is my B bar, and this is my B. Now if I have to write a function of this like Y, for this let's say I am writing here, what will be the answer? A, B bar. Okay, what will be the answer for this? Plus A, B. What will be the answer for this? This will be your A bar, B. Okay, so this is the answer. If we use the same method for using a K map, so in the K map, what we are doing? We are using a gate level minimization. So what if we try to draw this function with the help of a gate? So let me draw. So let's say we have got this A. If I have got this A here and I have got B here. So let's say if I put a A bar, so I will be getting A bar here, not gate. I will be getting a B bar here. So how I will get this A into B? How I will get this one? So for this, what I required this function A and B. We will be getting this A, B bar. Okay, how I will get this AB? I will be getting this AB like this. AB. Okay, and how I will get this A bar B? A bar B I will be getting like this. And then what I'm doing? I'm combining this all. So this will be my Y. What we are doing with the help of K map, we are using a gate minimization. That means this gate which we are using, we will going to minimize this gate level. How many number of gates we will be using? So now see this same question. Now we will going to solve with the help of using K map. We don't have to take 0, just for the sake of simplification I have put it 0 here. So we don't have to take the 0. Now we will draw a K map for this. A, B. So this will be my B bar, B, A bar, A. Okay, I'm using again same function 1, 1, 1, 1. What I have to do first, I have to see the maximum pairing. Can I do the maximum pairing of 4? Maximum pairing of 4 is possible here? No. So we will go for the maximum pairing of 2. So we can see that I can make a 2 here. Okay, so I can get one answer from here and I can use another one. I will going to take the answer. So what will be the answer of this? here what is common? You can see here A is common, so I will get the A from here. And here what is common? B is common. You will get the answer B here. So what will be my output? Y equal to A plus B. And if I draw this with the help of A and B, what I will be getting? I will be getting the answer only A plus. So see, in the top, how many gates required? You required 1, 2, 3, 4. 4 gates. And here how many gates you required? You required only 1 gate. So in above, you required 4 gates, and here you required only 1 gate. The output will be same, because what you have done, the above one is known as your conical form. That means you have written all the mean terms. Okay, whatever the mean terms is coming to you, you have written all the mean terms in it. And this is the minimization level. You have minimized the things. Let me take another example. Example number 2. Okay, let's say if I have a function of a K-map given like this. This is A and this is B. Okay, so I have A bar here, A here, B bar here, B here, and let's say I have an output 1, 1 at all. So what will be my answer? What is the maximum possible pairing I can do in this? 4. So I can do this pairing. This will be going to represent your 1, because if I use this in this A bar, if I take this one, A bar has been changed from A bar to A and B bar to B. Okay, A has been changed from A bar to A and B has been changed from B bar to B. That means there is no common point coming in this. So answer will be equal to 1. We will going to verify it, that whether we are getting the output 1 or not. So how I can write this? I can write Y equal to as my A bar, B bar plus A bar B plus A B bar plus AB. So let's say if I'm taking this one, in this, can I write like this? A bar B bar plus B plus here I can take A to B bar plus B. Okay, what is B plus B bar? This is 1. What is this? This is also 1. So I will be left with A bar plus A. What is A bar plus A? It is also equal to 1. If I draw this circuit, how many gate I required? 1, 2, 3, 4 AND gate and one final OR gate also to combine it. And we don't want, one thing more, we don't want that if you have taken one pairing, okay, we don't want that you should repeat it. Okay, so let me take one more example. Okay, so let's say I want to design a circuit, okay, or I have a circuit like this. This is my A and B. Let's say 1, 1. A bar A, B bar B. So what will be the answer? So here can we do the pairing? No, we cannot do the pairing. So we have to take a individual term. We have to write this answer. What is this answer? A bar B. Okay, and what is the answer of this? We will going to write AB bar. So what will be my Y? Y will be equal to A bar B plus A B bar. Example of a 3 variable, sorry, 3 variable. So in the 3 variable K-map, if I draw the circuit like this, so what will be the, let's say I'm writing here A and BC, what will be the maximum pair I can have? 8. So I can have a maximum pair of 8. Then that means I have a pair of 8. If I'm not getting the maximum of a 8 pair, what I have to see? I have to see for the 4. So I can have a 4 pair like this, or a 4 pair like this. So I can have a 4 pair like this also. So how we are doing it? So you can have a 4 pair. Finally, you can have a 2 pair. So I'm not drawing every possible 2 pairs, but you can have a 2 pairs also. And even if I take an example of this, even you can have a 4 pair like this also. You can have a 4 pair like this. 1, 2, 3, 4. This will be also a 4 pair. So we can have whenever we are solving this K-map, we have to see what are the possible combination. And this is only the thing which I have taken, okay, with this help of a yellow. This yellow button is representing this blue one only. Okay, so this will going to be same. So sometimes you are not able to understand that how pairing is being taken. So let me take an example. So let's say if I have an output like this, A, B, C, and let's say I have an output like this, 1, 1, 1 1 1. This will be B bar C bar, B C bar, B C, B C bar, A bar, A. Is there possibility of to make a pair of 8? No. Is it the possibility of making a pair of 4? No. Is the possibility of making a 2? Yes, we can make a pair of 2. So we will going to make a pair of 2. So I can make one pair like this. So what will be the answer from this? BC. And what will be the answer from here? See here, you remember what is same? This B is same, but C and C bar was changing. So we will not going to take an element which is changing. What is common here? Is common. So what will be my answer? My answer will be equal to here A B. So my output Y will be equal to AB plus BC. Okay, so let's take another example. Let's say I have a, let's say, okay, 1 1 1 1 1 1 A B C. Here I am writing, and I am writing like this here. This is 0 0, B bar C bar, B bar C 0 1, B C 1 1, B C bar, and this is A bar A. Okay, now can you tell me what will be the, I take the pairing of 8? No, I cannot. Can I take the pairing of 4? Is it possible? Pairing of 4 is possible? Yes, pairing of 4 is possible. So how I can take a pairing of 4? See, first I can take a pairing like this. I take a pairing of like this. So here what answer I will be getting? I will be getting the A. Is another pairing of 4 is possible? Yes, you can see again we have this 4 is possible. Okay, and if I draw this one green, I'm just for the sake of understanding, I'm drawing here this pairing. So you can see this will be my B bar C bar, B C bar. This is 1 1 1 1 here, A bar A. Is there anything common in this 4 pairing? We have got a C bar common. Okay, we have got C bar common. So here from here, what you can see that this C bar is common. So from this green color, what I will be getting? I will be getting the answer bar. So what will be my output? Y equal to A plus C bar. So let me take another example. If it is clear, do this one. Yes. Can you do this? Yes. So what will be the max? Can I take the pairing of 4? Yes. So I can take a pairing of 4. So I can make this like this. Okay. So from here, what I will be getting the answer? I will be getting a C bar. Now, can I make a pairing of this? So what answer I will be getting here? I will be getting the A, and what is common here? B. So I will be getting the answer B. So what will be my output? Y equal to AB plus C bar. And one more thing, there can be the possibility that the K-map answer which you are getting may be different from the someone else. Why? Because sometimes it's happened that when you are making a pairing, the pairing is been made in such a way that you have to always reduce the number. So sometimes it may happen that the pairing which you are making is different. Let me take one example, quick example I will going to take just to make it clear what I was saying. So let's say if I have got a pairing like this, 1 1 1 1 1 1. Okay, so this is one way, and let's say I am drawing this again, 1 1 1 1 1 1. Okay, so first one, this is first one, and this is your second one. So this is your A B C. So here B bar C bar, B bar C, B C, B C bar, and this is A bar A. Similarly, I am writing here B bar C bar, B bar C, B C, B C bar, A bar A. So here when I will go for the pairing at the top, I can make one pairing like this, I can make one pairing like this, I can make one pairing like this. So what will be my answer? My answer will be Y equal to, if I take this one, my answer will be A bar B bar. If I take this first one, let's say second and third. If I take second one, my answer will be A C, and for third one, my answer will be B C bar. In second one, if I going to make a pairing in a second one. So I have another way of pairing it. What I can do is that I can make a pairing like this one. I can make a pairing like this, and I can make a pairing like this. Okay, so let's say this is my third one, this is my first one, this is my second one. Okay, so what will be my output? Y equal to, can you tell me? First one is B bar C plus, here what I will be getting, A B plus, what here I will be getting, A bar C, be A bar. Okay, A bar, C bar, B bar, C, and AB. You got this? Okay, so in this way you can see that using a same K map you can have a two solution. Okay, so thank you everyone. I hope you have enjoyed this K map lecture today. Thank you.